14.1, graph sine, cosine, and tangent functions. And in this lesson, we're just going to do the sine and cosine part, and there'll be a part 2 for tangent. You're not really going to understand this comic until the end of the lesson, but this kind of looks like the cosine graph, so take a look back after we graph cosine. Let's start with graphing the sine function. So what you have to remember is your unit circle. Drawing it can be your biggest hint. So remember that this point right here was 1, 0. This point, 0, 1. Over here we were at -1, 0. And then down here, that's 0, -1. When we talk about the radian measures, we started at 0, then half the circle was pi. Remember, this was pi over 2, because cut that in half. And then 3/4 of the way around is 3 pi over 2. When we completed a circle, we could also call it 2 pi. So this was 0 or 2 pi, and then we could go around again. But that's enough to get our basic graph going on here. Remember that sine was equal to opposite over hypotenuse. And in our unit circle, our radius was always 1. So our hypotenuse was always 1. And here's our degree measure. And our opposite was always just the y. Because remember, this point right here is x comma y. And so our opposite is y, and our adjacent would be x. So on our unit circle, the sine of theta is simply the y coordinate. Because of that, when I go to graph the sine function, I'm just looking at the y coordinates. Now look at our graph here. On the x-axis, I'm going to be plotting radian measures, which is simply my theta. And on the y-axis, I'm going to be plotting y equals sine theta. Meaning on the x-axis, I'm going to be plotting the radian measures. So this is going to be my x-axis stuff. So at 0, 0, I plot the point 0, 0, 0 right there. At pi over 2, I plot the point 1, pi over 2, 1. Then I go over here. At pi, I plot the point 0. At pi, I plot the point 0. At 3 pi over 2, I plot the point -1. At 3 pi over 2, I plot the point -1. And then I go over to 2 pi, which is again 0. The sine and cosine functions both oscillate, so you can just go ahead and trace the same thing out on this side, or you could go backwards through the unit circle. You see that you have -1, -1, then 0, then 0, then 1, 1, and then we go back to 0. And so that's how I get my sine graph. We'll talk a lot more about the range, the period, and the amplitude coming up. Before we go graphing the cosine function, look at this little comic. Jack periodically exhibits signs of madness, and the sine graph we just saw goes through the point 0, 0 and kind of looks like that. So these both look like sine graphs. We're going to do much the same thing to graph the cosine function. So start with your unit circle. Again, here we're at the point 1, 0. Here we're at 0, 1, -1, 0, 0, -1. We need to plot our radian measures. We're at 0, pi over 2. Halfway around was pi. And then we're at 3 pi over 2. 0 is also known at 2 pi, and we could have gone around again. Now in this example here, we're doing cosine. And remember, cosine x is equal to adjacent over hypotenuse. And so in our unit circle, we know again that the radius is always 1, so the hypotenuse is 1. And the adjacent, because this is the point x, y, that means we go over x, up y. The adjacent is just x. And so here we have cosine theta is dealing with our x coordinate. So we're dealing with the x coordinate this time. So let's look at our x stuff. X stuff. Just like in our last example, the x-axis is going to be dealing with our radian measures, which is our theta. So we have 0, then we have pi over 2, then we have pi, and then we have 3 pi over 2. And our y-coordinate this time is going to be cosine x, which corresponded to the x thing. Don't forget that. That's a highlighted. So let's get started. When our radian measure is 0, our y-coordinate is 1 in this case, so we need to plot the point 0, 1. When our x-coordinate is pi over 2, our y is 0. So pi over 2, 0. At pi, we plot -1. At 3 pi over 2, we plot 0. And then at 2 pi, we go around the full circle, we plot 1. Again, we can go backwards. So let's just go backwards around. We start at 0, and then -1. And then we go back to 0, and then we go back to 1. And so that's how we get the graph going on here. Remember that the cosine x is simply that x stuff that we highlighted in our unit circle. Just like here, we were highlighting the y-coordinate because we saw that the sine of theta corresponded to the y stuff. Now here are some important characteristics of y equals sine x and y equals cosine x. We'll see that the domain is all real numbers because we can keep going around the circle as many times as we want, forwards and backwards. The range, however, is only -1 to 1, and here I've looked at the sine theta, and you can see that we never go higher or lower than 1 and -1. Reason being, and you might want to take notes of all this stuff, the radius of the unit circle is simply 1. So the highest value that sine can ever be is 1, and the lowest value that sine can ever be is -1. On the unit circle, we're never going to get a length of greater than 1. The amplitude is simply half the difference of the maximum and the minimum values. The amplitude is simply this part right here, which is equal to 1 in just the simple y equals sine x and y equals cosine x before we do any transformations to it. Each of these functions is periodic. You see that repeating pattern. So we need to define a couple of things. A cycle is just the shortest repeating portion of the graph, and the period is the horizontal length of each of those cycles. So what do I mean? Right here would be one cycle around the unit circle. So that's a cycle. The period is how long did that take? That took 2 pi. It took me 2 pi to complete one cycle. This is going to be the same for both the sine and the cosine graph. Let's look over at cosine. You'll see that one cycle, one time around the circle, we went from here to here. So even though we started at a different point, we started up here to begin our cycle, this is still one complete cycle. So our period is 2 pi. And the x-intercepts are simply things that you can pick up from looking at the graph. You do not need to memorize these at all. You just look at the graph. This comic is pretty funny. So now, of course, we're going to do some transformations of this, y equals a sine bx and y equals a cosine bx. The amplitude is simply the absolute value of a. We need to make sure that it's always positive, that amplitude. What you want to think when you're thinking amplitude is how tall is it from the center to the highest point or to the lowest point. And since we're talking about distance there, that's never negative. So the amplitude is simply how tall it is from the center of the graph to the highest point. The period is going to be 2 pi over the absolute value of b. Write that down for 1 second, and I'll explain it better in the next slide. But basically, the period is just how long it takes for the graph to complete one full cycle. And that's what you want to keep in mind. So when I go to graph any of these functions, I do it much the same as I've done any other transformations in this class. I start with the base function, and the base function would just be to plot x and then y equals sine x before I do my transformation. That 3 is going to affect the x stuff because it's attached to the x. So let me just start by drawing my unit circle. Remember, we're at 1, 0, then 0, 1, then -1, 0, and then 0, -1. 0 pi over 2 pi 3 pi over 2. So when we're looking at sine, we're looking at the y stuff. So you might want to call this theta if that's confusing you, that it's x. This is simply the radian measure, so we go 0 to pi over 2 to pi to 3 pi over 2, and we complete the cycle at 2 pi. That would be one full time around the circle, right? And so what are the y coordinates? Since we're dealing with y, let's do the y coordinates, and I've changed that to theta. Doesn't matter what you're labeling these things. 0, 1, 0, 1. Then we go 0, negative 1, 0, negative 1, and then we go back to 0. Okay, so that's just basically y equals sine theta. That was how I went drawing this right here. I go 0, 0, then I go pi over 2, 1, then I go pi 0, and you'll see all those points here. Okay, but now I said this 3 affects the x stuff. Remember from before that we always undo the x stuff. Before we saw that we had like x minus 2 squared plus 3 or something, y equals that. And we remember that we went 2 units right. That always undoes it. We always go the opposite way. So this, instead of being times 3, is going to be divide x stuff by 3. So divide all the x stuff by 3. 0 divided by 3 is still 0. Pi over 2 divided by 3 is pi over 6. Divide that by 3, we get pi over 3. Divide this by 3, well, 3 divided by 3 is just pi over 2. And then 2 pi divided by 3 is 2 pi over 3. So now we have enough information to go ahead and graph this, and I'm just going to graph one period. So I'm going to go 0, then pi over 6, pi over 3, pi over 2, and 2 pi over 3. Just to make sure I didn't make any mistakes, think about this. This is a unit circle, right? We've just identified that one cycle around, otherwise known as the period, is 2 pi over 3. Look back. Didn't I just tell you that the period was 2 pi over b? And b was what was in front of the x? 2 pi was our normal period for sine divided by 3, because remember that 3 indicated that we should divide all the x stuff by 3. That made sense. The amplitude is simply 1, because we didn't do anything to the y stuff. There was no stretch indicated there. So our amplitude remains at 1. So now if we redid our unit circle and said that one time around was 2 pi over 3, well then half of 2 pi over 3 should be right here. Is it? Half of 2 pi over 3 is pi over 3. Yep, I did it right. And then divide that into half, right? Because that's right here would be half of that pi over 3, which is pi over 6. So I did that right here. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 if I was counting in pi over 6s. So since this is pi over 6, I could have redone my unit circle. That's how some people teach it. Could have redone my unit circle that this is pi over 6. So we have 0, pi over 6, and this would have been 2 pi over 6. 2 pi over 6 reduces to pi over 3. That works. 2 pi over 6, 3 pi over 6. 3 pi over 6 reduces to pi over 2. That works. And then, let's see, we're at 3 pi over 6. 4 pi over 6 reduces to 2 pi over 3. So you see that I'm continuing on my unit circle. I'm going equal widths here to here, here to here, here to here, here to here. They must all be equal widths. Otherwise, you know you did something wrong. So that's a good way to check your answer. We go up and down 1. That was our amplitude, and that's what we found here. So when I go to graph it, I have the point 0, 0, then I go 1, 0, negative 1, 0, and that would be 1 period. We do the same type of deal when we're dealing with cosine. So since I changed this to theta in the last example, I'm going to do the same thing. So let's start with the base case, which is y equals cosine theta. We have the same 0, pi over 2, pi, 3 pi over 2, and then 2 pi. That's always going to be the same, right? Because that's always on our unit circle. And now, since we're dealing with cosine, that's x stuff. So that's 1, 0, 1, 0, then negative 1, 0, negative 1, 0, and then we end up at 1 again. Okay, so that's just the x stuff because I'm dealing with the cosine. And since that 3 is out in front, that means that we multiply the y stuff by 3. And so, of course, that's going to affect our amplitude. This graph's going to be much taller. So our amplitude in this case is going to wind up being 3. We haven't done anything to the x stuff, so our period is not going to change. It's just going to stay at 2 pi. And let's prove that to ourselves as we do our transformations. We go through, and this just affects the y stuff. So multiply by 3, multiply by 3, multiply by 3, by 3, by 3. And so go to graph that. Again, let's just do one period. So we have 0. We have not affected the period at all, so these numbers stay exactly the same. All we've done is make this thing 3 times as tall, so let me make it taller. We're going up to 3, we're going down to -3, so we have 0, 3 is where we start. Remember, this is cosine, so we're starting up. And it's going to look like that. Make sure that you get your shape going right. And that's it for cosine. So let's put some of this together. We're going to be dealing with a cosine graph. Changing that to theta, yeah? So let's just do the same thing we were doing before. Let's do a graph, theta, and then start with the base case, which in this case is cosine theta. And then we'll apply our transformations after that. So we start 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Go back here. Remember, our cosine is our x stuff, 1, 0, -1, 0, 1, 1, 0, -1, 0, 1. Remember, we apply our transformations in order. So first, we stretch the y stuff by 3. So times 3, times 3, times 3, times 3, times 3. And then this, we want to undo this. So we want to actually, instead of multiply, because here this is a multiplication, we want to divide the x stuff by pi over 2, aka multiply, because multiplication is easier, multiply by the reciprocal, so multiply the x stuff by 2 over pi. Remember, keep it, change it, flip it. When we're dividing, we can just multiply by the reciprocal. That's easier. So let's multiply all the x stuff by 2 over pi. So multiply by 2 over pi. That crosses everything out. We just get 1. Multiply by 2 over pi. Those cancel out. We just get 2. Multiply by 2 over pi. The pi's cross out. The 2's cross out. We get 3. Multiply by 2 over pi. The pi's cancel out, and we get 4. So don't get freaked out if you're just dealing with numbers on this side. That's okay. Let's just go ahead and check it. Our amplitude should just be this number out in front, the 3. Yep, it is. We go 3 up and we go 3 down from the center. And our period is simply 2 pi over that number that's in front of the theta. So that's pi over 2. Keep it. You see why I said multiply by 2 over pi? And so that should be 4, and our period was 4, so it all works out. So let's go ahead and graph one period. We're going to go 0, 1, 2, 3, 4. We're going to be going up 3 and down 3, because those were our biggest and smallest points. And then simply do what it says, 0, 3, 0, 3, 1, 0, 1, 0, 2, -3, 2, -3, 3, 0, 3, 0, and then 4, 3, 4, 3. That looks a lot like a cosine graph, stretched out a bit. To conclude this lesson with some humor, the first sign of madness, of course, our sine graphs looked like this. They started at 0, 0, and they looked periodic. And why do they call it pi if you can't eat it? Seinfeld. And just go back to your very first comic and you'll see why he was emo cosine. The cosine graph, of course, looked something like this. If we wanted to put our axis in, it would have been right around there. Beautiful emo cosine. And that's it for this lesson.
Bye.